Refraction in spherical mirrors. Before talking about the mirrors, let us see what is, we will define some terms like center of curvature, pole, radius of curvature, how to find out whether it is positive or negative. See, suppose if you are taking a spherical surface like this. In the spherical, this is the center of the spherical. It means if this is a principal axis, we consider, we remove this portion. See, for the surface, if the ray is coming like this, so it means this is the incident point. Here, in case of mirror, if it is mirror is like this, then it will get reflected because this side is polished. But whereas this is air medium, some other denser medium, so since it is a transparent medium, it will get through this medium, from this medium to this medium. It means it gets refracted at the interface. Suppose now if you remove this one, the center of curvature for this one will be here, and this is a spherical mirror. Here this is a denser medium or a rarer medium. If it is rarer medium, see the center of curvature is located at this point, not here in front of this, at this point. And if the incident ray is striking here, striking at this point, say at this point, and at this point, anywhere. So how to draw the normal? This is the center of curvature. See, from a circle, this is the center of the circle. If you draw a straight line on this point, for this point this will be 90 degree, and for this point this will be 90. Same way, if you draw a perpendicular at the points of incident to the center of curvature, this is the normal for this ray. And for this ray, this is the point of incident. From point of incident, draw a line up to the center of curvature. This is the center of curvature. That is normal. So incident ray making angle with the normal. This is the angle of incidence here. Incident ray with the normal, angle of incidence. So it means very simple. If you want to find out the normal at any point in the curved surface, because at curved surface the normal will be different. In case of plane mirror, the normal will be always like this, parallel for plane mirror. So, but not in the case of spherical mirror. In spherical mirror, the normals will differ, and to find the normal at the point of incident to the center of curvature, draw a line that becomes normal to that point. So, in case of this is convex spherical mirror. Why we call it as convex spherical mirror? Because already we have seen in this mirror, the bulging portion is reflecting, it will reflect, it will come and it will go like this. So here painted, so ray cannot go. But in case of convex mirror, convex lens, convex surface, it means here this is air, and this is rarer medium and denser medium, and the ray goes like this. So with the center of curvature, we draw the normal. This is the normal, and with this is rarer to denser, it will bend towards the normal. So it will go pass into the second medium. If the second medium is transparent, it will pass into the second medium. Thereby, refraction takes place between these two medium. This is convex spherical mirror. Convex spherical mirror means where the ray strikes, that side will be bulging. So if it is like this, now we take a spherical surface here, and here this is the center of curvature. Now we draw the principal axis like this, and we remove this portion. And this portion, if it is denser, this is rarer. Here the center of curvature here, if a line strikes like this, strike this point, this is denser medium. So this is the center of curvature. From center of curvature, what you do? At the point of incident, draw the normal. That is the normal. This is the normal for this incident ray. At this point, you die like this. If the ray is incident like this, this is the normal. So normal drawing is simple. At the point of incident, up to center of curvature, draw a straight line. That will be normal at that point of incident. But you have to see where the center of curvature is, behind or in front. That we have to see. So it will be, this will be normal. From rarer to denser medium, if the ray is going, it will burn. Instead of going like this, it burn towards the normal. Rarer to denser means towards the normal. So the ray is supposed to go like this. It will go to, and it supposed to, when you extend it back where it is refracted, it will meet here. So this is how we draw the normal, and we identify if the reflecting portion, this is the reflecting portion, is depressed, that is concave mirror, concave's refracting surface, refracting surface. So it means we can say for a convex mirror, convex spherical mirror, convex spherical surface, refracting surface, the center of curvature is behind this one, and for this one here, this is the formula. So center of curvature will be here. At this point, if we raise striking, we draw a normal to this point. At this point, that is the normal. This is the incident ray. This is normal. Convex spherical refraction. Convex means what? This is convex means where the ray is incident, that portion will be bulged. So I will take like this. Second thing, assumption made. See, this is the part of the sphere. This is called this diameter, effective diameter, for which the incident ray can pass through, is called aperture. This diameter of the spherical surface, or this diameter of the spherical surface where this refracting medium is exposed to the incident ray is called aperture. This one, aperture. And we take the aperture should be, for this deriving this equation, the aperture of spherical surface should be small. 2. This is regarding, and the angle of incidence, angle of refraction, and angle of center of curvature. Angle of refraction, angle of all are small. So that we can use the approximation, paraxial approximation. We can use paraxial approximation of angles. That is, what is paraxial? For a small angle, that is, sine of the angle is equal to the angle itself. Tan of the angle is equal to the tan of the angle itself, and cos of small angle is equal to 1. Note this, these both are same. It means we can see theta can be equivalent to sine of theta, or theta can be equal to tan of theta. So we can substitute anything. In place of sine theta, we can substitute theta. In place of tan theta, we can substitute tan theta. In place of theta, we can, in reverse also possible. Theta may be sine theta, theta may be tan theta. That is called, if angles, incident refractions are small, it means the paraxial approximation angles can be used. This is the paraxial angle approximation. Then for small aperture, we say small aperture it will have, and the sign convention. Sign convention, what it says? Suppose this is the optical medium in which suppose this is the optical medium, maybe concave or convex, and this is the principal axis. This is the ray going towards the optical medium. So from the center, the distance will be measured. This will be kept, this we call it as a pole. This is origin for measuring the distance. It means the distance are measured from the pole. And if suppose the object is kept here and from the pole we measure the distance like this. And if you are coming against, this is ray direction. And if you are measuring from the pole against the ray direction, that is negative distance. If the image is formed here, and we measure the distance from here to here. So we are going along the ray direction. It means the distance measured along in the direction of ray will be treated as positive distance. So that we have to remember. Second thing, how to draw the normal, we understood. Now this is bulging portion is exposed for the incoming rays. So when we take this one, this is convex spherical refraction. Convex spherical refraction means, as usual, this is pole. Pole is the center point of this refracting surface. This is pole and this is principal axis. So this is rarer medium, medium to, this is air, that is, sorry, this is denser medium. This is rarer medium. Okay. Now the assumption is the object is point object. The object we are using is point object, which is kept on the principal axis. So this is the object, say O, kept on the principal axis, and it is a point object. So this is an assumption. It is not having height. Height means then we have to find out h, that is height of object, height of image. But now here there is no problem. Since it is a point object, we need to calculate only the distance from the pole up to the object, up to the image, up to the center of curvature. The center of curvature will be somewhere here for this center of curvature. So this is the pole. Since a light from object goes like this, one goes like this, because we have to trace up the image. To trace up the image, we need two rays. One ray we have taken. So this ray is normal to the refracting surface. Why we call it normal? This is center of curvature. This is center of curvature. If it is center of curvature, and at this point this strikes, it means from this point up to this, that is normal, and the ray is going along the normal. So angle between normal and the ray is 0. It means it will go without any deviation. It will go through and through. So it will go like this. Now this ray at this point is incident. We can draw normal here. Normal means at the points of incident, draw up to the center of curvature. This is normal for the surface, and this is rarer medium, denser medium. As we are told, the ray is supposed to move like this. We expect the ray to move like this, but it will not move because there is a change in medium. At this point, we call this point as E. At this point, we can call this point as E. At this point, the ray is supposed to move, but it will bend towards the normal when it is going from rarer to denser. This is the normal, this is the direction, and this ray will bend towards the normal. It means instead of going like this, it will bend like this. So it will bend and go like this. Now you see, from the object there is one ray and one more refracted ray is coming. At this point, they are intersecting, forming the image of the point object. So it is real object. Why we call it as a real object? Real object means if two rays are coming and intersecting at a point, if the image is formed, that image is real. That is, actually two rays are intersecting here, actually two rays are intersecting. So this is real image. But otherwise, if from the object one ray goes like this, one ray goes like this, they will not intersect anywhere. So they will never intersect. So we will extend it backward where the image is formed. When the image is formed, if the image seems to be converging, diverging, that is diverging, the point of intersection is called image, and that is a virtual image. You can see if extended backwards, the rays from this point seems to diverge, then that is a virtual image. This is the difference between real image and virtual image. And because both the rays from the object cannot intersect, so when it is extended backwards, it intersects at a point. It seems to intersect at a point and forming image at that point where it seems to intersect and seems to diverge. That is called virtual. So we have to remember what is virtual image and real image. In this case, now the image is, because actually intersecting, it is image is real. So first case we say convex mirror, we say real for real image, and object kept at rarer medium. See, this is rarer medium, here is rarer medium, so object is kept here. So this is medium. Medium means it will have a refractive index of mu2, or we can say mu. We do not know. And this is refractive index of air. This is refractive index of air, which is equal to 1, which is refractive index of first medium. This is first medium. Rarer medium or first medium we can call. Now we drop a perpendicular from here. We call this point as N. Now see here, since the aperture is small, if the aperture is like this, then this point N and A will have difference. So both will not collide. If the aperture is like this, the point N will move towards the pole. It means, in fact, you cannot distinguish the point. This point N will move towards, the point N will move towards P. In fact, we cannot distinguish between point P and N. It means we assume that for small aperture, point P and N are almost coinciding. It means if you measure the distance from N to O, it is as good as equal to measuring from P to O. So this point we have to remember. Now we are drawing for real image. Real image, how it will form if you keeping away, and the principal axis, if you keep the point object at a distance, at certain distance away from the focus. Remember the convex mirror, away from the focus at finite distance. Yeah, real image formed. When the virtual image is formed, when it is kept closer, that is between the focus and the pole, if it is kept, virtual image will be formed. So now let us see here. So a real image, this is a real image. Object is kept on principal axis, and the object is point object. With this condition, we are drawing the equation for this one. Okay, now we have done, there is a ray like going like this, there is a go like this, now this is the normal and this is the incident ray. The angle between the normal and the incident ray is equal to angle of incidence. So angle of incidence. Okay. And now this is the normal and this is the refracted ray. The normal, between normal and refracted ray, this is angle of refraction. Since it is refracted at this media, because of different in media, and this is transparent, it will go inside after refraction, either bending away or bending towards, but in this case rarer to denser, it will bend towards the normal. So we have done like this. The angle made by the object by this ray with respect to the principal x, we call it as alpha. The angle made by the refracted ray with the principal x is beta. Then angle made by the center of curvature with the ray, the center, the normal and the principal axis is gamma. We take it as a gamma. Now with this we have to find out what is alpha, beta, gamma. Now we have studied already in the mathematics, if there is a triangle like this, and we have angle A, angle B, this is angle C, and this is angle D. This is angle D is external to this triangle, angle ABC is internal to this triangle. Now in the 9th standard mathematics you studied the external angle in a triangle is equal to sum of the opposite interior angle, not this angle, these two angles, right? So it means we can say the exterior angle is equal to sum of opposite to interior angles. That funda we are going to use it here. Now we want to find out alpha. How to find out alpha? We'll take the triangle OIC. AC. And with respect to, we have here two triangles. Triangle AC, triangle AC. What here will come? AC with object, AC with the image. That is AC with the image, AC with objects. The two triangles will take this triangle, this triangle, this triangle. What is this triangle? This is first triangle is ACO. This is C, this is A, this is alpha AOC. Okay, for C now we have this is angle of with respect to this one. This is angle of incidence, and this is alpha, and this is gamma. Angle of incidence alpha, gamma. It means this is external angle. The external angle is equal to sum of opposite interior angle, alpha plus gamma. So it means we can say I is equal to alpha plus gamma. First, second, from the triangle AC object, AC image. AC image, what is AC image triangle? That is, it will be like this. So AC, so this is C, this is beta, and this is angle of refraction. And what is this angle? This angle is gamma. So if it is gamma, this is CI. So it means this is exterior angle is equal to sum of opposite interior angle. Or we can write gamma is equal to R plus beta. But we want R and I and R. So R is equal to gamma minus beta. So therefore we can write it R is equal to gamma minus beta. So two relations we have already drawn it. Now we have found I and R. Since the refraction is taking place at this interface at E, the interface is taking place. This is the interface at E, the refraction is taking place. We will use Snell's law for refraction. Snell's law. What it says, Snell's law says is refractive index of one medium and its sine of angle is equal to refractive index of second medium into sine of this one, angle of refraction. Now we can use this approximation. What is the approximation? Sine I is equal to I. Approximately equal to I. Sine R is approximately equal to R by using approximation of paraxial approximation. So it means we can write, instead of sine I and sine R, we can write mu1 into I is equal to mu2 into R. What is I? I is equal to alpha plus gamma. I is equal to mu1 into alpha plus gamma is equal to mu2 into R is equal to gamma minus beta. Again, we use this in this triangle. Let us say take this triangle. In this triangle, we want alpha. Where it is alpha? Alpha is available in this one, in this triangle. That is A, N, O. This is alpha. We can write so we can write tan of alpha is equal to alpha. Approximation. So alpha, what is tan of alpha? Alpha is equal to tan of alpha. So tan of alpha is equal to An. Tan of alpha is equal to An by NO is equal to An by NO. So since N and P are closer, we can take, instead of NO, we can take PO also, divided by PO. This is tan alpha is equal to alpha is equal to tan alpha is equal to this much. Then we can write tan alpha gamma. Right? Where is gamma? Gamma is this triangle. That is A, C, and E. So this is gamma. This is gamma. Gamma is equal to tan of gamma. Tan of gamma is equal to An by Nc. An divided by Nc. What is Nc? N to C. N to C, we can say P to C. So An by Pc. Because Nc is equal to Pc since both the points are almost coinciding. Now, alpha, gamma, then we will find out beta. Where is beta? Beta is here. Beta is this one, this triangle. We can find out that is An, this is beta, this is E, this is N, this is I. So beta is equal to tan beta is equal to, what is tan beta? An by Ni, or we can write An by Pi. So we have written everything. So tan alpha is equal to An by Pi. So we have find out alpha here, gamma here, and alpha, beta, and gamma. So we will write now, we can write the instruction equation now like this. Since, so we can write beta is equal to An by Pi, gamma is equal to An by Pc, and alpha is equal to An by Po. Therefore, rewriting all this one, since place is congested, by rewriting all tan alpha, so mu1 by alpha, mu1 into alpha plus gamma is equal to mu2 into alpha gamma minus beta. So mu1 into alpha is equal to An by Po plus gamma is equal to An by Pc by Pc is equal to mu2 into gamma. Gamma is An by Pc minus beta is equal to An by Pi. Since An is common, we can take it out. Here also An is common. We can take it out and cancel it. So mu1 into 1 by Po plus 1 by Pc is equal to mu2 into 1 by Pc minus 1 by Pi. What is PO? The PO is object distance, that is PO is equal to object distance from P to O. Object distance, object distance. So which we are coming, this is the ray direction, we are coming from P, we are coming against the ray direction. Therefore U is minus object distance PO. So we can put mu1 into 1 by minus U plus PC. PC is this distance from here to here. This is a radius of curvature. Radius of distance from P to C, we are going along the ray direction. So this is positive. So R, we will write 1 by plus R is equal to mu2 into 1 by PC as it is 1 by plus R minus PA. PA is the distance from pole to image, that is V. V is along the ray direction, so it will be positive. So V is positive, 1 by plus V. So taking it inside, minus mu1 by U plus mu1 by R is equal to mu2 by R minus mu2 by V. Taking this mu2 this side, mu2 by V minus mu1 by U is equal to mu2 by R minus mu1 by R, which you can write mu2 minus mu1 by R. That way we can simply write this one. If we can write this one, mu2 minus v1. So mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This is the expression for the refraction in the spherical mirror convex surface. Convex surface. So how we can remember? Refractive index of denser divided by image distance minus refractive index of the rarer divided by object distance, refractive index in denser medium divided by image distance minus refractive index in the rarer medium divided by object distance is equal to refractive in denser minus refractive rarer by R. That is refractive index in denser medium by V minus refractive index in the rarer medium by U is equal to refractive index in the denser medium by refractive index in the rarer medium by R. This is the way how you remember. This is the expression for when refraction at the convex surface, refraction at the convex surface. This is a convex surface. The bulgy portion is in front of the ray. Or we can, if the refracting medium is air, if it is air in this case and its refracting medium is mu. So we can write refracting denser medium is mu by V minus refracting rarer air, its refracting index is 1 U is equal to refractive index 1 medium minus 1 and divided by R. This is the expression for refraction at the convex surface. Now refraction at convex spherical mirror surface when image formed is virtual. So we know that the image formed will be virtual if the object is kept closer to the pole, that is between focus and the pole. If it is away at finite distance, a real image will be formed. Now here, the image formed is virtual. So I will take the same surface when ray is coming from rarer to denser medium. There is a principal axis. This is the pole. The center of curvature for this will be somewhere here. So this is a denser medium mu2. This is rarer medium refractive index 1. So if you are keeping the object here, a ray will go like this, and normal at this point of incidence will be drawn from that point of incidence to the center of curvature. So this is the normal. So it means the ray is supposed to move directly like this, but the ray, instead of moving like this, it is going from rarer to denser medium. It will, instead of moving like this, it will bend away like this. So when it is bending, this is the incident ray and normal, this is angle of incidence. Now when it is forming, a ray from this object will go like this, and both will not be, this will go like this will go like this. So there is no point of intersection to form the image by these two rays which is coming from the object. So we will extend it backward. This is produced backward, will come here. When this is produced backward, this is image is formed here. So image is formed here. It means what? See, since from ray going from object, after refraction, it reaches there, it goes out there, and one more ray is going through the principal axis. So both rays cannot meet each other. So produce it backward, and the point of intersection when it is produced backward is with a point where the image is formed. Why image is formed? It means image is formed, it will be, the ray is here like this, then it goes like this, another ray goes like this. So it means we have to produce at this point. So backward, it means the image seems to converge from a, image seems to diverge from a point. If the rays are produced backward and at a point the image is formed, and from these seems to diverge from the point, that image formed is virtual. So this is virtual image of the object O. Virtual image of the object O. So now the principal axis, the rays, this incident ray is making an angle alpha, and this image ray with principal is making an angle beta, and the center of curvature with principal is making an angle gamma. So this is denser and it's rarer. So refraction takes place at the point of incidence at the interface. The refraction takes place, and since rarer to denser, it moves, bends away. Now we have to find out I. What is I? So from the triangle, see, we call this point as A. Then triangle A and AC with respect to object, and triangle AC with respect to I. So we will take this triangle to find out I and R, because we have to use I and R in Snell's law. So triangle ACO, where is the triangle ACO? It means ACO, this is the, with respect to normal, this is the angle of refraction. So ACO, where it is ACO, this is ACO, this is ACO, this is refracted ray. In this here, we can say in the ACO, I. What is I? This is I. This is I, with respect, I is making. So this is with O, this is alpha, this is gamma. So I is equal to alpha plus gamma. So we can say I is equal to alpha plus gamma, because external angle is equal to sum of opposite internal angle. Now next is ACI. ACI. This is gamma, this is beta. So this is the ACI, this triangle. So R, so this is R. External angle is equal to sum of two opposite interior angles. Or we can say R is equal to beta plus gamma. Beta plus gamma. So we can write it here. I is equal to alpha plus gamma and R is equal to beta plus gamma. Okay. Now we have find out I and R. Now we have to find out alpha, because by applying Snell's law, refractive index 1 into sine of angle of incidence is equal to refractive index of second medium into sine of R. Sine of R is equal to mu1 into sine of I is equal to alpha plus gamma equal to mu2 is equal to R is equal to beta plus gamma. So we have to find out alpha. What is alpha? Alpha we can write alpha is equal to tan alpha from this triangle. This we produce it here. We call this point as N. Because N and P are closer, therefore this is tan alpha is equal to, in this triangle, AN by NO. AN by NO. This triangle. This is a tan alpha, or we can write is AN by N is closer to P, so N can be replaced by P because NO and PO both are same. And beta is equal to tan beta. Tan beta means this triangle. AN by NI. AN by NI is equal to AN by N can be replaced as PI. And gamma is equal to tan of gamma, this triangle, this by this, that is AN by NC, we can write it AN by PC. So we have written, so we will substitute this value. Mu1 into alpha is equal to AN by PO plus gamma is equal to AN by PC is equal to refractive index of medium 2 into beta is equal to AN by PA plus gamma is equal to AN by PC. Now we have to give respect to the sign convention. What is sign convention? PO. This is PO. This is PO. This is the ray direction. We are coming against the ray direction. Once if you are coming against the ray direction, it is negative value, negative distance. This is object distance is U. So therefore, object distance U is equal to U, which is negative quantity. Same image distance. Image distance is pole to this side against the ray direction. So image distance is V, which is negative value. And PC, P to C, we are going this way from P to C. Therefore, P to C is positive value since we are going along the ray direction. Radius of curvature. Radius of curvature is C, which is equal to R plus. So we will put it in this equation. Here, what we can remove the A and out. A and out. When we remove the A and out, this will become mu1 by 1 by PO plus 1 by PC is equal to mu2 by 1 by PI plus 1 by PC. PC, okay, PO. What is PO? P2 is image distance. So image distance will be opposite minus of U. Object distance, sorry, it is object distance. Mu1 by 1 by minus U plus PC. PC is equal to, this is PC, radius of curvature, positive. So plus R is equal to mu2 into PI. PI is also from P to I here. It will be image distance minus V plus 1 by PC is plus R. So you have to give due consideration to the sign convention. So this we can write minus mu1 by U plus mu1 by R is equal to minus mu2 by V plus mu2 by R. So R, take it to that side, mu2 bring it here, this is mu2 by V minus mu1 by R is equal to mu2 by V, mu2 by R minus mu1 by R. So this expression, same as the expression. Last we have derived for the real image, also same expression. For virtual image also same distance. When object is kept in rarer medium, image is formed at a denser medium, that is real object. Object is kept in rarer medium, image is formed in the rarer medium, that is virtual image. For both, the expression is same. Or we can write refractive index of denser medium by image distance minus refractive index of rarer medium by object distance is equal to refractive index of denser medium minus refractive index of rarer medium divided by radius of curvature. If first medium is rarer medium, first medium is equal to A, then its refractive index is equal to 1, and second medium is a medium, unknown medium, so we can simply keep it at mu. So this equation will become, mu of denser, denser means mu2, mu by V minus mu or 1 by U is equal to mu minus 1 by R. This is the expression when object is kept closer to the pole and the image from this virtual and object is in the rarer medium. The refraction takes place on the spherical surface. The spherical surface is convex surface. Now we will be seeing a refraction when the object is kept in the denser medium. Refraction on convex refracting surface when object is kept in denser medium. So now here we are going to see object is kept, this is a convex mirror. So this is convex mirror, this is the principal axis. Convex spherical surface, this is the pole. From pole, the object is kept here. This is a denser medium. Medium 2, medium 1. Medium 2 and medium 1. This is denser medium. Refractive index mu2, its refractive index is mu1. And object is kept in the denser medium. So when the object is kept in the denser medium, you can say a ray goes here is this is object, this is center of curvature because this is a sphere and its center will be within this one, center of the, so it means with respect to center, we draw normal, this is normal. It means incident ray with normal is the angle of incidence, angle of incidence, I, angle of incidence, I. Now, since the ray is supposed to go like this, and ray is supposed to go this way, denser to rarer, it means it will bend away, the ray will bend away from the normal. If it is going from denser to rarer, it will bend, this is normal, it will bend away from the normal. This is the normal and it's supposed to go like this and it will go like this. This is. So here, there is a ray starting from object and along the principal axis, and one more ray this way, and both the rays are actually meeting at the point forming image. This image is here a real image because actually the rays are meeting at a point. The ray should actually meet at a point, then it is at the point of intersection image is formed, then the image formed is real. Virtual means it is not meeting from ray coming from the object is not meeting at a point and extended backward, then produced backward, then it seems it is intersecting at certain point and it is a diverging ray, then that image is a virtual image. So CO, so with the principal axis this ray making an angle of alpha, object is always alpha, image is always beta, and with the center of curvature is gamma. So now we call this point as A, this is point as N. So as usual we have done it. Now what we have to do, we have to find out alpha, beta, gamma. So we have to find out I, because it will be used first here, what is the step where image is kept, image is a point object, it is kept on the principal axis, either a denser medium or rarer medium. And first we will see I and R to apply it in the Snell's law. After applying Snell's law, we will find alpha, beta, gamma. To apply in place of I and R, in terms of I and R, solve it, you get the equation. That's all. No need to confuse anything. So alpha. So for finding out the alpha, what we will see? We will see first point A and center of curvature. Point A and center of curvature with the object with image. This is to find out alpha, to find out I and R. So this is triangle, this is triangle. ACO. ACO. In ACO, this is gamma external angle, sum of opposite internal alpha and I. So it means for ACO, in the ACO triangle, ACO, this alpha is outside external angle, the internal angle, opposite internal angle, I and alpha. So we can write gamma is equal to I plus alpha, I plus alpha, or I is equal to gamma minus alpha, gamma minus alpha. Let us try, see the triangle ACI, ACI, which is forming the external angle. So this is the normal and this is the refracted ray. So this is R here. So in this triangle, we are saying ACI. These both are internal angle. This is external angle. So we can say external angle is equal to sum of internal angle, gamma plus beta. Gamma plus beta. So we can write it I is equal to gamma minus alpha and R is equal to gamma plus beta. Gamma plus beta. With this is over. Now next is you have to apply this Snell's law. Applying Snell's law. So from alpha we have to find out alpha and beta. With this we have to take the triangle of alpha, triangle of beta, and triangle of gamma. First step is ACO, ACA, then second step is alpha beta. What is this? Applying the triangle refractive in the first medium, that is second medium is denser medium mu2 into sine of I is equal to, this is mu2 into I into mu1 into R. It's equal to mu1 into sine of R. Sine of R. So we can write mu2 into I. Sine I can be replaced by I because already in the start of the video said for small angle I and R all are very small angles, so that we can take sine I is equal to I, tan I is equal to I for small angle only. It's equal to mu1 into R2. So mu2 into I is equal to gamma minus alpha is equal to mu1 into R. R is equal to gamma plus beta. Gamma plus beta. Now we have to find out I and R. So we will find out I and R now here. So alpha is equal to tan alpha is equal to alpha. This is the triangle tan alpha OAN. Triangle OAN. This by this. This by this. That is AN by ON. We can say, since N and P are closer, we can replace N by P. So this is AP. We can leave AN also because AN will be kept. It is in the numerator for all the LHS RHS. It can be removed. We put AN or AP. It does not matter. AN by AP is equal to, we can say OP. We can write OP. ON we can write as OP. So tan beta. Beta is equal to tan beta is equal to tan beta. What is beta? Beta has been this triangle. So this divided by this is equal to AN divided by NI. Always remember, beta means image, alpha means object, and gamma means center of image, center of curvature. AP by N means PI. Similarly, we can write gamma is equal to tan gamma is equal to, gamma is this triangle. This triangle, instead of writing AN, we can straight away write AP divided by NC or PC. See, very easy to remember. Gamma means with the C, alpha means with O, and beta with I. So alpha means with O, beta means with I, gamma means with C. Easily you can identify. So we can put what is alpha, mu2, gamma. Gamma is equal to AP by PC minus AP by PO is equal to mu1 into gamma is AP by PC plus beta is equal to AP by beta means it is well understood PI. So this AP gets cancelled. So we can write mu2 by PC minus mu2 by PO is equal to mu1 by PC plus mu1 by PI. In this case, what is PC? PC is from here to here. It is radius of curvature, the distance of center of curvature with respect to the pole, which is we are coming. This is the ray direction. By according to sign convention, we measure from here to here. It is coming in the negative direction. It means R is equal to minus. PC is equal to mu2 by minus R minus. And PO, P2, this will also coming this way minus U because it is object distance, OP is the object distance, minus because coming against the ray direction. So mu2 by minus U is equal to mu1 by PC is equal to minus R plus mu1 by image. Image is formed from here to here, a long ray direction we are measuring. So image will be coming plus V. So we can write this one mu2 by minus mu2 by R plus mu2 by mu2 by u is equal to minus mu1 by r plus mu1 by v. So take the r one side. If you take the r, this r in this side, or we take this r this side, mu1 by r, this is this side, this is become this is minus mu2 by r equal to, since we have taken this one this side, we will take this one that side, that is mu1 by v, take this that side, is equal to minus mu2 by u, mu2 by u, or you can write mu1 by v minus mu2 by u is equal to mu1 minus mu2 by r. This is when the object is kept at denser medium. When the object is kept at denser medium, this equation holds good. When object kept at denser medium. So when object is kept at rarer medium, we can write mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Here, what is the difference between these two? This is when object is kept at rarer medium. Here uv stands as its place. In this equation, replace mu2 by mu1 and mu1 by mu2, you get this equation. So mu2 replace it by mu1, here mu1 replaced by mu2, and here mu2 replace it by mu1, here mu1 replace it by mu2. You can get this is if you are replacing. If you don't, the easy way to remember is if you first you should remember the equation when the expression when image is kept at rarer medium, that is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. And wherever mu2 is there, replace it by mu1. Wherever mu1 is there, replace by mu2. You will get the expression for when the object is kept in the denser medium.